Yes, inside.
In the local tissue.
That's
inside
right. That was yeah, exactly. That maybe 40 years ago.
And you would not be able to measure that T3 systemically necessarily.
No, absolutely not. That was in 24. So my thesis, we put rats in the cold room, and in 24 hours, the amount of T3 skyrocketed in the brown fat and didn't change in the blood.
And what was the fold increase in the fat?
In the energy expel, well,
how much T3 increase did you see inside the brown
about
fat?
tenfold.
Tenfold.
Yes. We saturated the receptors. The receptors were fully saturated. You couldn't have more because it was already fully saturated. It's really impressive. And then when we knock out the D2 in the brown fat, then the amount of heat produced was much less, showing that, in fact, that surge in T3 localized in the brown fat was really important. Now, people might think, well, I don't care about brown fat. Well, that so happens the same thing happens in the brain. Most T3 in the brain does not come from the blood, comes from being produced locally through the type 2 deiodinase. So what we learned from the brown fat, we actually took and used for brain studies. Our brain, most T3 in our brain is produced by the type 2 deiodinase.
Now the question that would immediately for me come from that is the hypothalamus responding to that T3 as its signal to make TRH, or is it seeing anything in the periphery?